A hollow tube has a length L, inner radius R1 and outer radius R2. The material has a thermal conductivity K. Find the heat flowing through the walls if the flat ends are maintained at temperature T1 and T2. That is in first part. Let's say this is my cylinder, alright, and let's say the outer one like this. So if the flat ends are maintained at temperature T1 and T2, so it is very clear that this is the shaded area where from heat will flow. So heat flow is given by Ka delta T by L. So let's say if the length is L, so K area will be only of shaded area, so it will be pi of R2 square minus R1 square T2 minus T1 by L. That is the answer. Now in second part, if the inside of the tube is maintained at temperature T1 and outside is maintained at T2, so it will be a case like this. Fine. Inner is maintained at T1, outer is maintained at T2. So again the thing here is that the area of cross section is varying throughout the passage because the heat will flow in radially outward direction like this. So I'll do the same thing as I did in previous question, that I'll take a differential cylinder like this. Alright, this is my differential cylinder. And I'll calculate dq by dt, that is again the constant, equal to K. Here the area will be equal to 2 pi r because I took this differential cylinder at a radius of r into dx, that will be the, or I can say 2 pi r into the length of the cylinder into, let's say, d theta is the temperature variation of this dx differential element divided by dr. Fine. So just doing the same thing again, I have C dr by r is equal to K 2 pi L into d theta, varies from T1 to T2, R varies from R1 to R2. So I have the same, that is K 2 pi L into T2 minus T1 divided by natural log of R2 by R1. Okay. This is my answer. Now note that in the previous question I did the same thing where the thickness of the disc was D. Okay. Now if I'll change that D to L, it will form a cylinder because of course the length will be larger for a cylinder. So in that previous question too, if I'll just replace D by L, I'll get the same answer.